Hey guys, today we'll discussing about Spark architecture and how DAG will be play a crucial role in terms of Spark and what happens if any job fails when you submit the Spark job. Yeah, come to the point just I'm recapping the earlier things. I already discussed this in details in the previous sections. As I told, Spark is a big data processing engine. Its main part, if you want to do, once you are reading data in a bigger files like in big petabytes or terabytes, you want to analyze some analysis on top of the data to handling such huge files and to make that job in parallelism and to make that job with 100% without dropping kind of scenarios. If you want to choose such kind of features, there is one more the option is Spark is one of the data processing tool we can pick it. So nowadays Spark API will be much popular compared to others like Hadoop and there is just like Spark, like there is a data warehouse. Some tools are there, but most of the people they will pick Spark as a for data processing. Like there is a there is a core reasons are there, right? Why Spark is much popular. The one of the core reason is it follows in-memory computation. Nothing but it will store the intermediate results in the in-memory. So whenever you store the data in memory, the processing time we can easily access that in-memory data into the processing area. And I think this Spark will support both batch processing and live data. That means like streaming data will support, and you can write the machine learning algorithms also. And it is open source platform. We can say we don't need to pay anything. We can use it as a free, and as well as it will support multiple languages. We can write these Spark programs in either Python or Scala or Java. These all languages will support by Spark. Jump into that how the Spark structure they will design to achieve this all that things and all. In the Spark structure there are different core components are involved. We have driver, we have cluster, we have executors, and we have different tasks involved. And there is DAG will be involved there. DAG have multiple stages and each stage have multiple tasks. This information will be there. So this driver holds information about the DAG schedulers. That means all DAG information, lineage information holds, and as well that the task informations. The DAG will hold as well as the program, whatever the program we are writing, that copy. Like suppose you are writing something like a Python file. You are PySpark file. This file have we own this into the driver only. So this driver will send this copy of logic to the executors, but that doesn't mean it will not send the full copy of the code. It will send the executors only a specific piece of logic. See here the responsibility of the executors need to process the data to it will deal on the data what need to process and how we need to process those details will given by these driver programs. See for us we have only one driver, but we have to deal that programmatically to process the data in a cluster. We have many executors, and each executors we have a capacity to deal with many tasks at a time. So to get the parallelism. See, this is a you can test that this is a node means these are the you can call it sometimes you can call it the worker nodes. So now we have three worker nodes in this picture, and for to maintain these three worker nodes, we need one manager. That manager we call as a cluster manager. Yeah, these are the key components in this. You can see in the picture also, like we have driver, tag scheduler, task scheduler, cluster manager, executor, this and all. These are the key things like a driver program, entry point of Spark application, runs with main function. Here that the actual thing we kickstart. The driver program have all the contextual information like Spark context, Spark session, and if you are storing any kind of like a broadcasting variable, something like a global variable. This all information will hold up the driver program level. The cluster managed responsibilities only maintaining the resources, will not deal any things related to a programmatical way. The responsibility of this is only maintain the resources which are free, which are busy kind of. Executors means here the actual work will be happening. These are the key workers. The driver is just, they will tell how need to do and what data, on top of what data I need to apply for particular piece of logic. Those things will tell by driver, the executor will execute that data and give the results back to the driver program. See here, in executor we have number of tasks. See how the tasks are divided based upon the DAG. DAG will have number of stages and each stage may have different tasks. See, the driver sends the following information to each executor. So as I discussed earlier, so driver have logical execution plan. That means, suppose when you write any piece of logic, suppose you are reading a file, spark dot read dot some file you are reading, CSV file. This file we hold this RDD1. On top of the RDD1, you are applying any map function, something applying some concept like 1, 2, 3, 4 values are there. You are applying something sparing out values like 1, 4, 9. These values will be coming. So by using some lambda function, you are applying this logic. These results will be stored into RDD2. And in RDD3, we are taking RD2 as the input and applying some flat map, and we are storing into RDD3. RDD4, we are applying some grouping functionality. This again will be stored into RDD4. So DAG will be hold the information, the lineage for means RDD1, RDD2, RDD3, RDD4. When action is called, like suppose RDD4 dot collect or some, when you are calling this action, then only this RDD will consult to RDD3, RDD will communicate with RD2, RDD2 will communicate to RD1, then the actual process will be started. If before that, as I told, executor levels, there are different tasks, and DAG will have number of stages. How the stages are created, right? Based upon the transformation, what transformations we are. In a Spark we have transformations and number of actions we have. And when it comes to transformations, we have narrow transformations, we have wide transformations. When you're calling that wide transformation, then the different stage will be created. When you are applying narrow transformation, stage will not created. In this case, the first to three RDDs will move into one stage. Stage 1. The second one, here we are calling group Y is a wide transformation. Here the data will be stored into stage 2. So that again, this moving to stage 1, this one is moving to stage 2. This is how DAG will be creating the stages based upon the what transformation we are using. So how why it is creating wide transformation, why you are calling means, suppose when you are dealing with the map function, map required map required only partition, it will work only partition levels, and no need to worry about that to some other partition data. So if you come to the group, for grouping data, it needs other partitions informations also. So in Spark, to achieve that faster computation engine means, when you are reading the input file, we are dividing into number of partitions. Suppose here 1 GB file is there. We are dividing into number of partitions with 180, 128 MB of data means 8 partitions. So parallelly, we are giving the same partitions data to different executors and different tasks. It is parallel working. This is how a parallelism we are achieving. To make this parallelism, and that will create the stages and they arrange the task. See, this driver sends this logical plan to the executors and stage metadata. That means a list of tasks. Like each stage may have different tasks. Like which task, which executor need to work on. That kind of information also driver program sent to the executors. And like task to executor mapping. This mapping information. This called meta information held by a driver. Just like under what. See here, like which logic closer nothing but like whether we need to apply on the particular task either flat map or map, which transformation we need to apply on particular set of data. Like it will send up like which partition of data also, like you need to apply this piece of like map on this map function on the particular partition of data. This information also sent by a driver program. Once the executor collected all the meta information from the driver side, it will start processing the data, and the intermediate data will be storing within the executor memory. That means executor RAM, or if it is that executor in memory, if it is getting full, it will be spilling to executor disk, not to a driver disk. So because of if data, the intermediate regions will have within a memory or within executor, it will be helpful for some other stages of data or other task when doing some computational things. See, this is how sample Spark submit command. So these are the all things we need to give while submitting the job tools. See, these parameters like number of executors, number of cores, and number of executors memory, these things all we need, as a developer, our responsibility need to pass based upon the like which transformation you are applying and which kind of actions you are using, and these all things like we can see in the DAG, and DAG will in like when I will show one session after while running the Spark job in EMR. There is like a Spark history server. Those UI side we can see like in a particular program. Like suppose you can see this is a Spark application. When you run the Spark application, this application will split how many individual tasks, like how many stages, like might be 20 or 30 stages, 100 stages will be there. Like each stage may have again multiple tasks. Those designs we can see based upon the task. Also we can decide like how much memory is required to complete our job. It's based upon the how much data we are shuffling from one partition to another partition. That is also another case. When you shuffling the data from one partition to another partition means we're applying wide transformations. Wide transformations are costly, so it needs more memory to do that work. See what happens when you submit the Spark. User submit a job. That means either Spark submit. Driver creates an RDD lineage. As I told, lineage is nothing but this one RDD1, RDD2, the stages and all. It holds that information. And DAG scheduler breaks DAG into stages. See, DAG have number of stages. The stages will be decided based upon the transformations. So which transformation you are using, either wide transformations or narrow transformations. The transformations are dependent upon the partitioning data. If a logic will be depend on other partition of data, then that logic will be called as a wide transformation. So in that case, we need to create one more stage for complete the task. Task scheduler will schedule the task on the executors level. The cluster manager will allocate the resources for complete our task. Executor runs a task and store the data as I told in memory, or if it is in-memory field, it will store into the inside of that executors. And one more thing here, right? Each executor have a JVM machine to execute this purpose. The Spark will be designing by following this by using this Scala language. and finally the result returned to the driver. Suppose if you are calling, you are something like mm, something, if you call like collect or show, if you call those things, the final results, the executor, the final results will send to the driver. Uh, or else, if you are calling like a something like a save as a test file or save as a some directories, some save as some, if you are giving some S3 location or saving from into HDFS, in that case, the executors will not send the output data to the driver. It will be sent through the directly to the destination area. If it is a case like you are sending data to driver, means driver don't have that much capacity to handle this output files. It will be again, the driver will be crash. Just for while working time, just if you want to show some, you want to see how it is results will be, then you can apply the driver level output, like a call is a collector, these things. Yeah, this part I already discussed. As I told, like the DAG will be created based upon the which transformations we are using. Like if you use this is examples for narrow transformation. This is a few examples for wide transformations. So here, like when it comes to narrow transformation, the data is not shuffling. That means the data, as I told, then our input data will be split into multiple partitions, and we're applying our piece of logic into the partitions level. If any piece of logic we depend on another data, then we need to defend, like we need to shuffle the data. Like this is some of the examples for shuffling case, like when you're doing some group by and something like hmm, something like analytical grouping operations. In that case, it will be where transformations are involved, or there like the data will be sapping from one partitions to another partitions. Here, for example, we are taking like four elements and splitting, but we are storing that element into two partitions. Suppose partition one we are storing 1, 2, and partition two we are storing 1 3, 4. This is partition one. This is a partition two. Suppose here we are applying x into x square. So to applying x square, no need to look on partition two. By looking to the partition one data itself, here itself we can do squaring, and we can store the results here in the same partition level. You are doing something summation of this worth, summation of all the data means, then you need to take a note partition, or else the start this from here to this partition, you need to take that results. The few questions may arise, like does Spark always write to disk in like a Hadoop? Spark will not write data always to disk. If the in memory is getting full, at that it is overflowed, then only the data will be spinning into disk. Disk is nothing but here a executable disk, not like a travel. What is the difference between task and stage? Like stage will be, a stage have multiple tasks. Like in a DAG we have multiple stages created based upon the transformations, and again each stage have multiple tasks, and each task we are assigning one partitional file. Here, like for suppose in stage one, earlier we are applying flat map. This is map is one task and flat path is one more task. Like we have for a stage one itself, we have multiple tasks within the same stage. When is data shuffle means when you are applying any word transformations, when you are dependent the from other partitional data, then only the data will be shuffled. How is Spark able to recover from the failure? The failures are getting from the with a DAG lineage graph. Suppose in the picture we are seeing like we have RDD1, RDD2, RDD3. While crossing the time of RDD3, you are losing the data. In that case, whatever the loss we can get it back from the RDD2. Like we can from the RDD2, again we will restart that work. We can recompute that same thing or what we lost in RDD3. So this is here like DAG will helpful to recompute. This lineage graph will helpful. Does does Spark create already lineage when using data frame? Yes. So internally data frames are also using RDDs and yes, like data frames also using RDD. Then driver use that uh, RDD lineage graph to maintain that tag. So what happens is already covered. Like what happens when intermediate data does not fit in the memory, it will be split into the disk. Who holds the final results. Suppose if call this current this kind of thing. In this case, will hold that final output. If you call any save as test file, save as Hadoop file, save as any S3 location, in that thing executor directly will write into the particular destinations. Once the job is submitted, who will send raw data to the executors and who will send a program to the executors? This raw data will be read by executors, and but with the help of a driver. Driver will tell the address like from which partition data need to read from which location. Those details will given by driver. This executors will read that raw data and what thing need to apply on that raw data also driver only tells that information. It will start the processing. The program also the piece of program also tell the driver like in this particular stage apply map function and flap on the stage to apply something like reduce by these transformations like this information will be helped by a driver program. Does Spark create RDD lineage when using data from? Yes, I already told. See what happens when you use data frame. What happens when you use SQL queries and RDD? Suppose if you use data frames, first will create the logical, then physical plan created, then RDD usually will be created at the driver side. If you call SQL queries also singular, or here catalyst optimized will be came to picture. The use of this catalyst optimized is making a query some optimization. The search engine will make some optimization. It will be helpful when you dealing with RDD. No need to doesn't there is no like kind of catalyst these things, so they will not help here. You can say like data frames are much faster than RDD because of these optimizations. When come to the optimization way, there is one more optimization technique is there like tungsten. This tungsten optimizer will help in terms of executors level, how we need to execute the task and how we need to it will tungsten will talk about how we can optimize the resources, and the catalyst will talk about how we'll optimize the in terms of the query planning. See what happens if node caches and the data is even the first RDD. Suppose, yeah, what happens if node caches and the data first in the first RDD means owner right RD tag will be created based upon the stages and these things. Before the stages will be dependent on the RDDs, like suppose RDD1, RDD2, RDD3. So these are all transformations. See, the stages will be created based on the transformations. If previously I showed if RDD4 fails, if it is getting failure at any crash, we will get it the same thing from the connected to the RDD3. So, but what if the case like if the RDD1 itself fails? If RDD1 fails, if suppose if your data you are using HDFS, we have replication factor, we can get it back. If you are can Spark also can recover the data from, because you're using something like if you are using, in that case Spark will recover. Suppose if I using AWS as a source file and in S3, so here we don't have replication factor, but AWS will give the 100% durability. In that can again we can get it back. See, suppose if you are dealing, if you are running the jobs in the, you are reading any data from the local disk, there is no duplication factor, means you can completely lost the data here. See, in some if your job is getting failed at RDD1 means it's not that much costly, right? Anyway or not, you are in the initial stage, you are okay to start again the job. But I think it is like you have 100 RDDs, you are failing at the 100 RDD means if you don't have this lineage graph means you need to start the work from the RDD1, but that is a costly operation. So when failures happens, there is some techniques are there to handling the uh, how our data should be secure. We have like something like caches, persistent and checkpoint. These are the some few techniques are there. Suppose persist is one of the technique. We can store that data in the particular disk level. Disk level here means like in executors level. And if you do catchy, if you do applying catchy, suppose RDD1, you can apply RDD at the end of the RDD4. If you store in the RDD4 in dot catchy, it is stored into that executor in memory level. We have different storage levels when you apply a persistence, like memory only, memory and disk, and disk only. This number 2 will be something like we need 2 copies of on that data, kind of like replication. See, if you apply persistent with memory only, store in RAM only one replica. If you apply disk only, store on disk, no, you will have to store on RAM. Like these are the list of several parameters we can use based upon our requirement. This is a snippet of code, how the persistence and things we need to use, like consider we have this, we are creating a Spark contest, and here we are reading a file into the RTD, and this on top of this RTD we are applying some filter function. This is a narrow transformation we are applying here. On this RTD we are persisting into the location of disk only with the 2 copies. Means in executors level it will store with the 2 copies. Come to the checkpoints. Checkpoints are nothing but we are storing this data not in our executors level. We are storing data into something like Hadoop environment or S3 environment, those things. Those information we need to give this location information we need to give this checkpoints. These checkpoints will mostly useful when we're running the jobs in the long running time. Suppose something like Spark streaming jobs, it is running like days, years, and all. If you remember the state information is not possible. If you check with the DAG, it will be very lengthy. The DAG information, the lineage graph will be lengthy, unable to store this lineage graph itself is important. In that case, if you do applying checkpoints, it will be, suppose if you are applying checkpoints in RDD4, no need to look up this, no need to maintain this RDD2, RDD3, this graph. It will be kind of a deletion. We can will when you last send something, it will be starts from the checkpoints. That means here checkpoints is RDD4 will be the checkpoint. Without checkpoint means it will start from the RDD1. With checkpoints, it will start with RDD4. This is something like summary of that cache persistent checkpoints. Here the snippet of code how we need to enable those checkpoints. See here we are giving the checkpoint location is a HDFS location. Spark context we are setting checkpoint directory. So when you are doing here, suppose here like RD2 or applying checkpoint, this RDD information will be stored into this HDFS location. I hope you understand little texture level, and the coming sections I will give more clarity, and if I miss any information about this Spark architecture and all. Thank you.